the pH of this particular cleaner, and again we can see somewhere between a 12 and a 13. We'll put it about 12.5, and that's the first thing I wanted to do, to determine what the pH of this cleaner is. And we take a little bottle of that original sample as it was received, and that's what it looks like. And we're going to try to break the emulsion here, split this into a clean water stream and an oily waste stream. Okay, this is the machine we're going to be testing on. It's got one of our standard pump and motors. We're using 3/4 of a square foot of filter, a membrane with 3/4 of a square foot filter surface area. As you can see, there's a lot of foam with this stuff, which means a lot of cleaner probably being thrown down the drain or gotten rid of when you guys do dispose of this stuff. So now what I'm doing is heating it up. Since I don't know the exact operating temperature, I'm going to go somewhere between 130 and 150 degrees, and we'll run our test off of that. Okay, basically what we're doing here, we've got the liquid that goes into the process tank. From there it gets pumped up through this hose, boom, into the membrane. There's actually 6 tubules connected by U-bends. So we put one of these actual filtering membranes look like. We got a little spot here that when they come in and we clean them, we put them on a device that we actually dry them so that we can send them back without any airborne microbes, getting in there and possibly fouling the membrane. When we first started cleaning them, we'd ship them back wet, and we had some problems. So we decided, let's put a little device on here that we can actually blow them dry. So as you can see, there's 6 total tubules on this thing. And when they're put together, they do connect them at the bottom and at the top with these little U-bend connectors. And then basically what happens is the liquid comes in, either side, goes up and down through all the membranes, and then the dirty material comes back out the other side, which will then obviously return back to our process tank. So all the contaminant and dirt, oil, grease, particles, and what have you end up in our process tank. The clean material permeates through the 1/10 of a micron filter. And again, that's the filter that you saw over there is now stuck inside of this housing. And then we do have a little permeate port, which we use right here to draw off the clean material. And that's running through the hose, down, up and into our bucket. Let's see if I can do this without falling down, because I can't see where I'm going as I'm trying to film what I'm doing. And there it is again, the clean water coming out here. So we got just under, we got 3/4 of a square foot of filtered surface area in this actual housing here. And as we start to force clean water through by turning the back pressure, we usually operate at about 30 pounds. I don't know if you can see that on the gauge. And then that will, instead of allowing the liquid to go right back into the process tank, by restricting the flow back through the hose into the tank, we start to push it through the pores of the membrane, which is a 1/10 of a micron. So what will happen is the clean water will start to fill up this vessel. And once it builds its way up, the liquid height comes up to a point here where we're going to draw it off on this little hose here, our permeate return flow. And let's see if we're getting anything back yet. Take a quick look here. There we go. That's our clean material. I'm going to get a bottle and collect some of that and see what it looks like. Into the tank, through the hoses, into the membrane. We restrict the flow so it starts to push the clean material through the pores of the membrane, and it will fill up our vessel, and then we'll be taking off some clean water here, and I'll get a bottle to show you what that looks like. So we're back. Getting some clean permeate. Let's get a look at what this stuff looks like. Here we go. So you can see now we're getting nice clear permeate. And this is what we're going to look for here is a clear permeate, and we would hope to see some foaming action, which means we're bringing some of the soap across as well. Let's see if I get a little better shot here. That's the permeate returning into the container. There we go. This is the permeate, or the filtrate if you will. As you can see, nice and clear compared to what we started out with originally here. Give you an idea what the two look like. Obviously you can see that it is quite dark in color. The foaming indicates that there is definitely surfactant that is in the dirty cleaner. And again, as you can see, probably here, if I can get a little close-up, we're foaming as the water hits the bottom of the bucket, which again, whoops, oh, I lost the picture, sorry about that. Is an indication that we've got a lot of available chemistry that has been being gotten rid of and disposed of. So with this, just so you can see here, we've already processed, oh gosh, almost 9 liters. Again, this is the clean, filtered permeate, or filtrate if you will. As you can see, we got a color body, which is not unusual. Dyes from oils and things like that will pass through the filter, but no pigments. And it's not unusual to see a little bit of a yellow or an orange color body for the permeate, but you can see it's nice and clear, as is once again demonstrated on this bottle of permeate that we grabbed right off the initial run. And that's the story. And let's take a look at how dirty our source material is compared to when we first started here. I think you can see this is a little bit lighter in color, and the dirt and oil that we've been taking out of all this stuff just continually is maintained and stays behind in our process tank. Hopefully I'm not blocking the camera. You can actually see the clean material falling into the bottle. Obviously a little more turbulence, you can see the foaming again, basically bringing over all the nice chemistry that is still available in that particular batch of cleaner that you guys sent me. So basically, you see again how we can continually filter and clean up this material for reuse. And I just wanted to give you a shot there so you can actually see the bottom get filled up. You see it getting a little bit, again, more dark as we move along here. Obviously, all the clean water that comes out. With that 15 gallons, we had a gallon of oil. We're going to end up with a gallon of oil with a little bit of water left over. So obviously, take that 15 gallons out of the mix, you're going to have a lot darker looking leftover concentrate, or retentate is what they call it, than what the original sample looked like. Of all your material into the machine. So now we're just going to batch down what's left in here. Again, we'll get a little bit of a look at what the stuff looks like. And we are still permeating. And about 230 mils, which is where we were when we started. What's left in this tank will be our concentrate. And we'll figure out how many gallons we processed or over how many gallons we have left to give you a rough idea on the volumetric reduction of waste by this process, which I'm going to gather is going to fall probably in the 95% realm thereabouts, which means, roughly every 100 gallons we process, about 90 to 95 will go back in the wash tank, and we'll pull the rest out as contaminants. Last of your material, if I can get a good angle here to get an idea of what color that's looking like. That's pretty thick and dark now compared to the original stuff. And again, we'll have a bottle of that to put right next to it to give a good comparison. And just give you another look at what we've got in the tank. Getting near the end of the run here. As you can see, oh boy, I'm guessing we've got probably less than 3-4 gallons to go. And we're still getting a pretty nice run here. Just